I wanted to give you the different impression of here. We're doing the future of transportation, but if this was ideas 2119, and I was giving you the history of transportation, what would I say? And I've kind of reinterpreted this question very recently. I just became a father about 6 months ago, and it kind of harked back to a conversation I had with one of my friend's kids about 5 years ago. He came in, he was asking his mom, they said, "Mom, why do you roll down your window?" He's 8 years old. He had actually never rolled down a window his entire life. But yet, he said, "Why do you roll down your window?" So when I look at the questions that my son will ask at some point when he's 30, 40 years old, what was driving a car like? What's a driver's license? What is taking a slow plane? What is taking a slow rail? How did you get around before Hyperloop? And these are the questions I think that really make it exciting to work on the future of transportation. But more importantly, I think a couple of the other presenters went through this very, very graphically. Throughout the history of time, there has been profound change when you connect things together better. From Roman roads, Spanish ships, transcontinental railroad, the highway, even the internet. Internet's just a form of connectivity. It's digital, it's not physical. But what we're trying to do is connect people physically and do that in a time scale that is unlike anything they've seen. You could get from New York to Washington, D.C. faster than you could get uptown New York. And just think what that could do for the types of industries, the types of technology that you can put together. And so rather than reinvent everything you hate about transportation, all the things you hate about trains, let's talk about a 21st century solution for a 21st century problem and not talk about an 18th century solution for a 21st century problem. And so what is Hyperloop? At the high level, it's land-based transportation that's moving roughly the speed of an aircraft. How do we do it? Well, we have a tube, as you've probably seen in most of the videos. That tube gives you a low-pressure environment. It's like flying at 50 kilometers altitude or 200,000 feet. So as you heard earlier, you could go the speed of an aircraft for roughly a little bit more than the drag that you'd have on a truck, going at about 100 kilometers an hour. Inside these pods, which hold about 25 people, you can either move air cargo, not rocks, or people, about 25 people per pod. We're using our form of magnetic levitation, which has gotten an extremely bad rap for, I'll say, previous generations of maglev is never working and being too expensive and really never being mass manufactured in any way. The advent of small-scale power electronics, computer density, as well as battery technology has allowed us to put a 20-pound package into a 1-pound package and do that in a far more efficient way than they were able to do it 20, 30, 40 years ago, either with the German system or the Japanese system. System's 100% electric, so no direct emissions. It's pulling the best from solar panels that you can see. In addition, it's actually not utilizing anything that is active on the track. So one of the big key differences here is that we're using an architecture that has a very dumb track. So what's the best analogy that you could have for that? It's a road. A road is very, very dumb, right? A Model T could drive on the same road as a Model S. And that's the beauty of a road. There's no moving parts on the road. There's nothing expensive on the road. And that ability allows us to have quite a high throughput. We're talking about moving 16,000, 20,000 passengers per hour on this type of system in our India project, 150 million passengers a year. And then doing that, you can't do that with drivers. You're going too fast. You have to make too many decisions too quickly. So when we talk about AI and machine intelligence to control these pods, that's exactly how these autonomous pods are working. Think of truck convoys, think of autonomous vehicles, making decisions because taking the human out of the loop in this case actually enables the vehicles to run quite a bit more efficiently. So what we've seen around on some of the other presentations I think is really fascinating in terms of exponential growth with regard to energy, but also with respond to consumer demand and need, which is the fact that people are looking for electric solutions, getting off oil, covering the top. In this part of the world, the entire top of the tube can be covered with solar panels. So you could actually completely unplug this from the grid and have a system that does not require any additional electricity than what it can generate on its own, which I think is a very attractive thing for a future transportation system. It's substantially more efficient than air travel. There was a question in the last session for Spike that was about where's the sweet spot for Hyperloop. And the answer, I think, was pretty spot on. Hyperloop is not meant to go your last mile. It's really between about 50 kilometers and about 1,500 kilometers. Less than 50, you're going to hop on an autonomous vehicle, vertical takeoff and landing vehicle. bus, metro, whatever it might be. Anything more, you're going to hop on a supersonic aircraft. And that's really the sweet spot that we're trying to do, is get people to where they want to go when they want to go there. And so rather than have these really long 600,000 person trains, you're filling up these individual pods that are going direct to their destination. And more importantly, they're not stopping at every stop along the way. They're getting off at an exit ramp. And that's all enabled by really the technology that we've got. Last part on this is really how it fits into a right-of-way. One of the things that's really difficult about linear infrastructure projects is getting the land. And so by having a system that can bank in a tube like an aircraft can bank rather than a high-speed rail, you can go along existing highway corridors substantially faster while still maintaining something that doesn't make every passenger sick, throw up, or more importantly, make the dog vomit on your baby, which is always something that we're worried about when we're on the train. So for us, safety, number one, you heard before the earlier presentations talk about safety and how difficult it is to get something safe. So while an airplane really has to deal with an FAA, our pod looks like a plane, the tube looks like a train, the control system looks like an air traffic control, and we have to deal with a variety of different safety organizations. But the fact that we're in an enclosed tube makes our system so much easier to, I'll say, create the autonomous system for than a normal car, because I'm not worried about the case where a ball goes out in the road. I'm not worried about the ball, but I'm worried about little Jim following the ball. I don't have to worry about that. Here in the Middle East, one of the high-speed rail projects they're doing in Saudi is having quite a bit of issues with camels walking across the track, sand blowing across the track. The number one cause of accidents is because there's at-grade crossings where objects, vehicles, people can cross tracks and cause problems. We don't have that. We mentioned the fully autonomous, and the other thing I really want to drive home about our vehicle is what I would call a solid-state vehicle. It actually has no moving parts. So when you look at maintenance, when you look at things that can go wrong, when you look at wear and tear, there's no steel wheels grinding on steel rail. There's no bearings. There's nothing that gets hot. There's no engines. You're looking at basically a large vehicle that's completely controlled by electricity, which I think is the way you see every vehicle going on the road, every vehicle you'll see in the sky. We're just happening to do it in a tube. The other thing that was really important is we started this about 4.5 years ago in a garage, and the number of times I got laughed out of a fundraising room, I think, was very ego-demoralizing. But no one ever believed that we could actually build it. And so what we had to set out to do was show that we could build it. So we're based in Los Angeles, where we have about 150 people. In Nevada, about 30 minutes outside of Las Vegas, we actually have a demonstration facility, our test track, DevLoop as we call it. So it's about 500 meters long. It's about 3.3 meters in diameter. And we began constructing that in November of 2016, and we finished in April of 2017. And then we began to do testing. And that testing was to demonstrate all of the key aspects of the system: the vacuum, the levitation, the propulsion, the control system. And make sure that, more importantly, each one of those things that worked independently in our labs actually could work together, because that's not a guarantee. And after we were able to demonstrate that, we started seeing a shift. We started seeing a shift from people that were not interested in funding. We started seeing a shift in projects. We'll talk about projects in a second. We started seeing a shift in investors and the type of people that are interested in working on this. So Virgin became an investor in our company because they don't develop technology, Virgin, but they buy technology like a Boeing plane, like an Airbus plane, and they operate them. And so for our system, that's what we decided to do. So in this short track, we got up to about 240 miles an hour, about 400 kilometers an hour, in about 300 meters. So that's accelerating at about 2.5 Gs. So 0 to 60 in about a second. So take that, ludicrous mode. And then we slowed down. More importantly, we came to a stop and didn't come out of the back part of the tube. We won't be doing that to grandma on the pod. This will be like an aircraft taking off. So you'll experience something that is like an aircraft to take off, but you won't have the turbulence, which I think is something that is really exciting for people that actually don't or are scared of air travel. As a response to that, we had quite a bit of progress on projects around the world in the last 18 months after the successful part of that testing. So in the US, we have 4 key projects. You see them in Missouri, Colorado, Ohio, and then in Texas. You see kind of the beginnings of a national network. The same way the Transcontinental Railroad really redefined the US as an industrial power. You see that happening with these Hyperloop projects. In India, and I'll talk about India in a second, our furthest along project connecting Mumbai and Pune, about 120 kilometers, something that takes about 5 hours in a car on a good day on a very dangerous highway, you can do that in 25 minutes. And more importantly, in Mumbai alone, this is a staggering figure, 8 people who die per day riding the trains. Just think about that for a second, 8. When I read that in a study or a New York Times article, it was just shocking and staggering. But when you go see the transportation system, it's not actually that surprising. Here in the Middle East, and we'll go into a little bit in more detail in a second, again, you're seeing the network effect becoming. How can you connect this area in a way it's never been connected for? What if I could start in Riyadh and I could connect all parts of the GCC in less than 2 hours from a single distribution hub? Connecting the new mega cities, mega projects that are working there, connecting Abu Dhabi to Mecca within less than 2 hours, being able to go out for Friday prayer and be back maybe slightly after lunch. But the idea of bringing people together, being able to connect, the key essence of what we're trying to do is connect people and enable people to do what they want to do. So the other thing that we see is the impact of being first. So what are the benefits of being first? So if you're the first one to build the test track that we're working on now, you have the benefits of not just the people that are working on it, but the people that will become the maintenance technicians, the people that are working on the actual control system, the laws, the regulations. And so when we're localizing that in this particular area, we're not buying steel from other areas, we're not buying concrete from other areas. We're bringing that expertise here, and then that first 1, 2, 3 projects will be able to distribute that to the rest of the world, that knowledge base. And so we see, on the order of millions of jobs kind of being created from this indirectly, just from having a network effect in the long term, but easily tens of thousands of jobs in the near term. And so we look at the UAE network. This is kind of one of the easier ones. You'd see Dubai to Abu Dhabi. Obviously, there's ramifications of this, but you could see these independent stations that allow you to go direct to your destination. You're not going to stop at each one of these places along the way, but you're connecting within 12 minutes. But the idea is what it could do in this network quite a bit broader. In the GCC alone, there's about 4,000 kilometers of Hyperloop that you could build. This area of the world doesn't have linear connection. They want to have high throughput. You're not going to be able to move 20,000 passengers in A320s. That's an aircraft taking off about every 45 seconds, just going to one destination. So when you're looking at the amount of people that you're trying to move, the volume, look about the Hajj, the pilgrimage that people are trying to have, this is really an enabling aspect of that. And we look at the visions here. We're linear infrastructure projects. It's not something that gets built in a day, in a week, in a month. It's going to be built over time. The things that we see in the Middle East with the Vision 2021, Vision 2030, about how you connect things long term, that's really in line with our timelines as a company, because to build this, you need the wherewithal of a vision that's going to be here for multiple years, not that changes every 2, every 3, every 4 years. That's why you see state levels in the US as being some of the first ones. That's why you can see national levels here in the Middle East as being the next logical ones. And most of them, the attraction of job talent and high-tech industry is something really exciting, and that's something that we can offer to everybody, or to these first ones. So what does our timeline look like? We built a prototype about 2 years ago. We have about 3 more years of development of that. The analogy I like to use is what you saw in that video is roughly like a World War I aircraft. And if you go back and you look, some of those had 1 wing, some had 2, some had 3, some used flaps, some used wing warping, some had people just fall out of the planes immediately. For us, we have to go from the World War I aircraft to, maybe not the best analogy today, a 737, maybe a A320. And you don't have the benefit of World War II. You don't have the benefit of all that time in between to actually do the development. So we have to make it economically viable, scalable, as well as safe as the expectation for passengers getting on it. That would result in roughly a 12-kilometer demonstration facility, certification facility. And then we'll do our certification approvals on that facility, which will eventually become a route. Now, depending upon how long that route is, India would start commercial operations in 2028. There's no reason you couldn't have some shorter routes that might come in at 2026 type of timeframes. And so the last thing I'll mention here, as an engineer, our job is to enable human behavior in a natural way, but to do it in a sustainable way. Our job is not to say, don't do something. It's, this is what you want to do. Let's find a way to do it better, more innovative in a way you never thought possible, but do it in something that doesn't destroy the environment we're trying to preserve. It allows people to see the people that they want to see, and more importantly, it gives them the time back that they want to have. And so with that, I'll turn it back over.
Awesome. Have a seat. Amazing vision. And I've been to your dev loop in Nevada and seen some of this vision like actually being constructed. What are you learning about something that's so new and so radical once you actually get to the point of physically building something?
I think it's one thing to say you're going to do something. It's something completely different to actually see it all the way through to completion. Because saying that you're going to climb Everest is very different than climbing Everest, right? It's the essence of getting in, it's the training that goes into it, but more importantly, it's dealing with things that don't go right. And that's why engineers test. We test because we're not perfect. We test to become perfect. And this gave us the ability, like for example, the first couple tests we ran, there was a behavior that we knew about, but we had dismissed as secondary. And I did basically the failure awards for my team afterwards. And so we had a little bit of a mishap is too strong of a word, just a off nominal behavior is what us engineers like to call it. That resulted in a couple of shavings. And so on my one engineer's desk, who's responsible for the dynamics of the vehicle, he has these shavings and with a little plaque that says, when secondary physics become primary. But that learning process that little nugget has actually resulted in the commercial vehicle that we're doing now, using this like piece of physics that we thought is kind of secondary as a primary piece, largely because of a result of a test learning.
And it is such a new concept and so different to things that have gone before. I mean, there's some similarity to rail and to maglev and various other ideas, but put all these things together and it's very different. Is there a chance that you'll actually start developing this and realize that maybe this idea actually doesn't quite work? I mean, does that ever give you pause?
Yes. What we built up there that we showed the video before, if we try to build that system commercially, no one would buy it. It's far too expensive. It's not as reliable as we'd like. And more importantly, it's nowhere near the level of safety that we need to demonstrate for not astronauts. I mean, if you look at what a lot of the space companies are doing, I spent some time at SpaceX, they're going from nobody to astronauts in 17 years. We're trying to go from a garage to grandma's in 10. And that is a far different level of safety. But also we suffer from quite a few less failure modes than a big rocket that's people sitting on a bomb. So I think there's a lot easier of a chance for us to achieve it.
And we've done pretty well today talking about the future of transport without mentioning Elon Musk directly, although you did work at SpaceX. We have mentioned Tesla a few times. And the Hyperloop was originally a proposal of his, which he then sort of gave to the world and said, you guys go and develop it. And so your company and others are working on that. Is being an Elon Musk project these days, is that a benefit or is that a hindrance? I noticed you didn't actually mention that in your presentation at all.
My biggest personal fear is my tombstone will say, here lies Josh, he worked for Elon.
There are worse things in the transportation world. I mean, he's got some good ideas, but perhaps also has some very radical ideas, some of which he's developed, but others that are maybe just sort of, you wonder if they're his fantastic imagination.
I think what he tapped with the original white paper, and the tech that we've actually done looks quite a bit different than the white paper. He talked about air bearings, he talked about compressors. We don't have that. Our stuff actually looks the closest to a paper that was a 1974 paper by the Rand Corporation. But he tapped this latent desire that people are fed up with transportation. They're fed up with how long it takes for things. If I told my newborn he could only watch his show at 8 a.m. on a Saturday, he would think I'm a lunatic, like I'm a crazy person, right? But that's what we tell people every day on transport. You can only go when we say you can go. You can only come when the bus says it comes, only when the train says it comes. Why can't I turn up, get on the pod 2 or 3 minutes later, no matter what time of day I go? Or more importantly, why am I being told that I should only go to these destinations at the times that I'm being told to?
It's this paradigm shift, isn't it? And so perhaps with supersonic flight, like we heard about earlier, there's a precedent. We at least know that was possible, and passengers could fly, and now we just need to do it better. But you're having to do something that's very, very new, and I think maybe Elon Musk has that ability to push those ideas. With electric cars, for example, he made those sexy and exciting and acceptable.
So car company with no marketing team.
Right, but why don't you capitalize on that more? I mean, could you use the Elon Musk connection with this idea?
I think the challenge that we have is that it's not a car. It's not something that people can imagine, right? It's a plane without wings. It's a train without wheels. It's a car without doors. And in that capacity, they can see an electric car because it's just a car with a battery. But people have a difficult time seeing, like, what is a Hyperloop? If I asked the 100 people that are sitting in here with a Hyperloop, I'd probably get 200 answers. And trying to visualize that, trying to tell an experience that is so foreign to the way that people currently operate their lives, I think takes a lot of education. It takes better graphics than we currently have. And more importantly, it takes watching someone get in and get out safely. But if I told you today I wasn't here selling you a Hyperloop, I was going to tell you you're going to get in a couple 100-ton metal tube and fly 30,000 feet in the air, you would probably think it's more crazy than what we just did.
Fair point. So talk us through then, if you haven't got the graphics yet, what the passenger experience will be eventually. I mean, what's the idea?
My goal is to have someone never have to utter the phrase, I missed my train or I'm late. The concept of missing a train is because it goes on a certain timetable, right? If you get there at 6:02, you have to wait till the 7 a.m. train. And at the high-level vision I'm trying to convey is the minimum time from the moment you think about going somewhere to the moment you arrive. Not the moment you get to the station, but the moment you think about going somewhere. So that means an integrated experience, right? An integrated ticketing experience. Just like Uber or Lyft, I'm going to my final destination. But first mile is an autonomous vehicle. It's a vertical takeoff and landing vehicle. It drops me off at the Hyperloop portal. I then am able to go, get on. It feels like an aircraft to take off. No turbulence. I have roughly a passenger experience that is similar to a comfortable business class style seat. I get to the end, there's already my last mile waiting for me, whether it's another autonomous car or it's a metro system or whatever it is, that's tied in the whole way. And the amount of demand forecasting I can do is just really unprecedented. The way you can transfer data. Imagine if Uber knew 50% of their riders 20 minutes before they wanted them. Right? What can Uber do? How can they optimize their fleet better? And the same being true from our system as well.
So you said it would be kind of like a business class seat. So I'm sitting in the seat. So you're bored, and then it will feel what, like a plane? Like you'd be inside the metal tube?
It'd feel like a plane. You'd have potentially aisle 2 is really kind of the experience that we're looking with. A number of rows. Most of the passengers that we're targeting are just normal families or business travelers. If you're going to an airport, there's sort of a luggage rack in the back that you'd see on a normal train, so you can put some of your larger bags. For longer journeys that are more than maybe 30, 45 minutes, probably be a bathroom on it. Otherwise, the pod will turn into a bathroom, right?
And people always ask about, that actual experience of being accelerated. Is it going to feel like a fairground ride? Am I going to feel sick? What's it going to be like, traveling at that sort of speed on ground?
One of the first questions that we got when we came to Dubai was, will my eyes bleed when I'm going at that speed? And I said, when was the last time you were on a plane? Did your eyes bleed then? His answer was no. It's like, well, people travel at these speeds all the time, right? And it's not an insane thing to vision people traveling at 500-600 miles an hour. Instead of at 30,000 feet, you're just doing it here. The acceleration, most people can deal with a aircraft at takeoff. And the suspension system, the controls that we have on that would make sure that there's really no vibrations in there that are appreciable.
So I'd be able to sit there and read and be quite comfortable like I am on a plane.
Yeah.
And
coffee, you have that hot coffee, you probably, I would dare say, put it on your lap. You don't have to put it on the tray table.
Okay. So would it be limited to passengers, or is that your view at the moment, or are there other uses for this type of transport once you've built the network?
I think Air Cargo, our largest investor, is actually Dubai Ports, DP World. chairman Sultan bin Sulayem, who's the chairman of DP World as well, views this as the next shift in cargo transportation. We're never going to take rocks, we're never going to take these big heavy things, but 70% of the weight that goes on a train actually only makes up 20 to 30% of the revenue from that. And there's a very small, think of your Amazon style package, your on-demand type of things. As the world shifts to that, there was earlier talk about 50% of the people working from home. Where are they going to get their goods, right? In the US, actually let's use the GCC. Imagine a central Amazon facility in Riyadh doing same-day shipping to all four corners of the GCC within 2 or 3 hours. Last mile by drone, you have all of your inventory in one area, you're doing all of your shipping in one area, and that's really where I think the power comes from, and why Sultan is so excited about this, is that he can see where cargo is going